Everyone, I'm on Lee. I'm about to open new chapter, estimation today. I'm gonna introduce some new terminologies, estimator, estimate, and desirable properties of estimator. I like you to be familiar with new terminologies. Okay, keep in mind. Let's see what estimation is. Estimation refers to the process of determining a known value. You have a known value, then you want to know what is that unknown value. Estimating by a single value is called point estimation, while estimating a known value which falls within a certain range, okay, within a certain range is called interval estimation. For example, how long will it take to get to the top of a mountain? How long will it take to get to the summit? Then you may ask, how long will it take, okay, to several people coming down because they have experience to get to the summit. So you will decide, I think, how many beans are in the jar? What is the length of a largest mullet in the fish farm? What will be the batting average of that baseball player for this season in spring? What is the taste of a boiling kimchi stew like? You will stir several times and taste a couple of times, I think. So you may decide the taste boiling kimchi stew. As you know, there are countless situations you seek to determine unknown values, right? So how can we determine unknown values? We must obtain data, subjective or objective, especially data, then sample, and make estimations using appropriate method. So what is the appropriate method? We want to know. In other words, we need to know which statistic. What is a statistic? Statistic is the result from the sample, right? It was a terminology obtained from the sample should be used for a suggested estimation. Here, let's first focus on estimation of a population mean mu. Okay, population, there is a mean mu, a known value. To estimate mu, we need to obtain a sample and estimate mu using the specific statistic from the sample. What is a specific statistic? That's what we want to study in this chapter. Estimator, new terminology. Statistic obtained from the sample, capital letters sample, theoretic sample, right? Random variables. That is used for purpose of estimation is known as estimator. So there are so many estimator for some unknown value. Estimate, the value of estimator calculated from the sample, right? X1, small x1, x2, small xn is referred to as an estimate. So you better distinguish two terminology, estimator and estimate. It is simple. This is a random variable, estimator. Estimate is value of that random variable. Okay, small letter. Okay, next page. Let's consider potato field of 10,000 square feet at the foot of a mountain that is about to be harvested. We will attempt to estimate the average weight mu of a single potato from this field. In order to estimate the population mean, we consider a sample x1, x2, xn. Okay, this is at the stage of planning stage. For example, estimate for statistic derived from the sample, this sample. Person A like to use x1 plus xn divided by 2, only 2. Take this one and this one, last one, so divide by 2. Person B, 2x1 minus xn. He likes to use this one to estimate mu. Okay. Person C, what is this? This is the sample mean, right? X bar. Person C like to use X bar to estimate mu. Person D like to use median. Median is when arrange the samples in magnitude, the center of this magnitude is median, right? He want to use D, person D want to use median as an estimator. Which statistic among A, B, C, and D should be used to estimate mu? There are many others except these four, right? So we need a criterion for estimator, desirable criteria for estimator: unbiasedness, efficiency, and consistency. Unbiasedness refers to what is unbiasedness? Property of an estimator when its expected value equals the parameter being estimated. Say you know expectation of x bar is mu. X bar is one candidate of estimator. Then expectation of estimator x bar is equal to mu. Mu is what? Parameter being estimated. So x bar is unbiased estimator. In such cases, the estimator is said to be unbiased or unbiased estimator. That is unbiasedness. Understand that? Let's see A. A is equal to x1 xn over 2. That is 1 over 2 to x1 plus expectation xn, right? Then, what is the expectation of x1? We get rid of a subscript. You don't have to worry about subscript, okay? So 1 over 2, this one is mu, this one also mu. So it is mu. So A is also an unbiased estimator. How about this B? B, expectation of B is 2x1 minus xn. Is 2 expectation x1 minus expectation of xn. So 2 mu minus mu equal to mu. So B is also unbiased estimator. C, of course, unbiased estimator. D, it is not D is not equal to mu. The purpose here is what? Population mean mu, right? So, but this is not expectation of D is not equal to mu, except it is symmetric. If it is symmetric, then equal to mu, if symmetric. But if not symmetric, it is not mu. So D median is not unbiased estimator. That's why we do not use median any longer. Okay? But I told you briefly, non-parametric statistics, we use median frequently. Anyway, right now, in this class, we never say about median any longer. Okay, so let's see. X bar is unbiased estimator of mu. There are so many unbiased estimator as an example. So unbiasedness only is not enough. We add some more desirable criterion like efficiency. S square is unbiased estimator of a sigma square. S square is what? S square is like sample variance is like this, a small letter, okay? S square, small letter, x1 minus x bar square, x2 minus x bar square, xn minus x bar square. Some of them divide by n minus 1. What was the n minus 1? We call it degrees of freedom. We divide by degrees of freedom n minus 1 rather than n because dividing by n minus 1 makes sigma square, s square unbiased estimate, because it is a small letter, estimate of sigma square. See, we studied distribution of a sample variance. At the time, n minus 1 times S square divided by sigma square has chi-square distribution, degrees of freedom n minus 1. This one is a chi-square distribution. Its mean is n minus 1. Okay? We can prove it, but not here. Expectation of n minus 1 s square over sigma square is what? N minus 1 in theory. Okay? So n minus 1 cancel out. So expectation of s square is sigma square, right? That's why we divide by n minus 1, s square divided by n minus 1. Okay? So the reason we use degrees of freedom is this. You don't have to think about sometimes sigma xi minus x bar square over n when n is large. Okay? When n is big, then you can use this one, and s square sample variance is this one, n minus 1, when n is small. Some statistics textbook mention like that way, but it is not good. Computer always has one formula, this formula, always calculate sample variance with the degrees of freedom n minus 1. Okay? Efficiency refers to when one estimator has a smaller variance, okay, than another estimator. The former, smaller variance estimator, is considered more efficient. So variance of estimator, if variance of estimator is a small variance, then that estimator is better, is good. So we want to find out smallest variance. Okay, let's see here. X bar is here among unbiased estimator, the one with the smallest variance is considered as best estimator, right? It is reasonable. So it is a minimum variance unbiased estimator, we say. But it is another terminology. So I like to use just best estimator. Best estimator means minimum variance unbiased estimator. Okay, X bar is the best estimator of mu. S square, this one, is the best estimator of sigma square. So we like to concentrate X bar and S square in statistics. Okay. Another one is a consistency. Estimator is said to be consistent if, as the sample size increases, n increases, the estimate converge in probability. In probability, you can ignore this in probability. The estimate converge to the true value of a parameter being estimated. We say that estimator is consistent. We will see a couple of examples for consistency here next time. This ensures that with larger samples, sample size larger and larger, then the estimation becomes more reliable and accurate. Of course, that is a good property, right? Okay, okay. I introduced some new terminologies today, and as I told you, you better memory or you better know, keep in mind that terminology. Okay, thank you. Bye.